negative 1.96. Since this is a two-tailed test, we have the rejection region on both the tails of our distribution. So this one is for the left part and this one for the right part. Okay, so for the right part, here's our rejection region. Okay, so we have already plotted the critical value. Let's try to have our computed value or the negative 1.056. So, negative 1.056. As you can see, negative 1.0 is something around here. Okay, so negative 1.056. And as you can see, negative 1.056 falls inside the non-rejection region. I hope you still remember that this region up to this point is a non-rejection region. So, non-rejection region. This is where the negative 1.056 lies. Meaning to say, since that is not included in the rejection region, we shouldn't reject the null hypothesis. We do not reject null hypothesis. Or, we are actually failing to reject. We fail to reject null hypothesis. Again, to population of hypothesis testing. I have said before regarding the independent and dependent sampling. When we say independent sampling, this is if two unrelated sets of the sources are used, one set of each population. That is the independent sampling. And if if we are trying to have the dependent sampling, this is when the sources or the set of sources are paired or matched in one way to obtain the data representing both populations. So, an example of this dependent sampling is if we are going to have a before and after test. For example, before having this lecture, I have given you a test, and of course, I have the summary of the results. Then, I have teach you the proper way on how to solve that specific statistical problem. Then I have given you another exam, and that exam is a same set of exam that I have given you a while ago before we start having the lecture. So the before and after results, more likely the after results is actually dependent on the process that we have that the process of teaching that we have done, no, sa gitna nila. So, before and after test siya. Ayun yung sa dependent sampling. Now, again, when we say source, of course, the source of the data, we have the independence and dependence of a sample is determined by the source. And this source can be an object, like what I have said before, a person or something that yield a part of data. Now, let's have the hypothesis testing for the testing the difference between two means. So, meaning to say, two population ang gagawin natin dito. Large independent samples. So, let's have our example problem. Before that, let's have the definition muna ng topic na ito. So, in testing the difference between two means of large independent samples, the sampling distribution is approximately normal. Again, approximately normal yung distribution. Hence, we will use a z-test in our inferences. So, sorry for the typographical error. This should be letter R instead of T. Now, for the assumptions, first assumption in this topic is that the subjects are randomly selected and independently assigned to groups. Next, we have the population distribution as normal as our second assumption. And third one, the population standard deviations are known. Okay? Now, regarding the formula, we will going to use two formula. Let's have our first one. I'll just set my pen color into black. Okay. So, for the z value, let's have this x sub 1 bar. Oops. X sub 1 bar. This is a bar. Minus x sub 2 bar. minus mu1 minus mu2 all over square root of sigma squared sub 1, or this is your standard deviation of the first population, all over n sub 1, plus we have the sigma squared sub 2 all over the sample size of the second population. Now, this is the first formula. The second formula is definitely almost the same with the first one. X sub 1 minus x sub 2. These are all bar. So, they are the mean. Minus mu 1 minus mu sub 2 all over the the square root rather of the s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. Now, what are these variables? Z stands for the z-test for two independent samples. And these x sub 1 and x sub 2 bar are the mean values of the sample of the population 1 and of course the population 2. Now, this sigma squared sub 1 and sigma squared sub 2, these are the variances. Take note, when we say sigma, then it has a squared. It is a variance and it is not a standard deviation. So, these are the variances of the population 1 and population 2, the first and the second population. And S stands for the variances of the sample. Okay? Again, sigma squared sub 1 and sub 2 is the variances of the population, while S squared sub 1 and sub 2 are the variances of the sample. Okay? Of the population 1 and the population 2, or the sample 1 and sample 2, since they are just a sample and not a population. Now, for the n sub 1 and n sub 2, meaning to say, this very basic, no? Sample population ito for group 1 and the group 2, or the first set of data and the second set of data. Mu sub 1 and mu sub 2, and it is actually minus sila, no? Mu sub 1 minus mu sub 2. This is the observed difference. Again, take note of this one. These are the observed difference. Difference of what? Difference of that two set of data. Okay, so observe difference. Next, so the standard error of the difference, actually, this is the denominator. This is called the standard error of the difference, either on the first formula or in the second formula. Now, let's have our example problem. First example, testing the difference between two means, large independent samples. So, here we have a real estate agent that compares the selling price of two townhouses in two major cities in National Capital Region, or the NCR, to see if there is a difference in price. Now, the results of this study are shown below on the table. Is there enough evidence to reject the claim that the average price of a townhouse in Quezon City is higher than Makati City? Again, take note on the last part of the problem, last sentence of the problem. Average price of a townhouse in Quezon City is higher than, we have used the term higher than Makati City. So, meaning to say, the claim here will be the alternative hypothesis. So, at alpha level 0.05. Okay, so let's start writing our hypothesis. For our null hypothesis, H sub 0, this is mu sub 1. Our mu sub 1, by the way, and the mu sub 2, let's have our labeling here. The Quezon City will be the mu sub 1, and the Makati City will be our mu sub 2. Okay, for the null hypothesis, we have here mu sub 1 and mu sub 2. Now, what will be the sign? Of course, since they are claiming that the prices of the townhouses in Makati City is less than Quezon City, or the other way around, Quezon City's price of the townhouses is higher than Makati City. Therefore, that will be for the alternative hypothesis. For the null hypothesis, babalik na rin natin siya. Now, it will be less than. Okay? And since this is a null hypothesis, there must be an equal sign. So, less than or equals. Just like what I have said, for the alternative hypothesis, we have h sub 1, mu sub 1 is greater than mu sub 2. And this will be our claim. Okay, so based on the problem, this will be the claim. The level of significance. For the level of significance, we have the level of significance equivalent value of 0.05 given from the problem. Okay, so here it is 0.05. Next, we have now the critical value. Okay, so for the critical value, this will be a one-tailed test since we have the direction. So let's write here one-tailed test. One-tailed test since we are having the direction. So the critical values based on our level of significance 0.05 and one-tailed test. If you'll check this on your table, I hope you have the statistical table with you right now. This will be positive 1.645. Just look on the alpha level and the one-tailed test on the table B. Okay? So, that's it for the critical value. Next, for the decision rule, or rather, for the test value, before we have our decision. For the test value, again, we will going to use the formula x sub 1 minus x sub 2. This is actually mean. So, we have bars here. So, mu sub 1 minus mu sub 2. All over square root of s sub 1 square ys, because as you can see, we have a sample size. So we're just using a sample here. So that is the reason, because again, based on our variables s squared or s sub 1 squared and s sub 2 squared are variances of the sample of the group 1 and group 2, or the first data set and second data set. In our case, that is the data set of Quezon City and the data set of Makati City. Okay? So, let's have this over n minus 1 plus s sub 2 squared over n minus 2. Now, we can directly input the values given from our data set. So, x sub 1 bar, this is the mean of the Quezon City. So, where it is. Here we have 2,140,000. So, 2,140,000 minus the x sub 2 bar of the Makati City. So, 1.97 or 1,970,000 over, this is just the x sub 1 bar minus x sub 2 bar, minus, we have here minus before we over. Now, as you can see, guys, we don't have the value of the mu because we are actually done using the mean, and this is the only mean there, the sample mean. So, the population mean, since we are having mu sub 1 and mu sub 2, and like what I have said before, this mu sub 1 and mu sub 2 is an observed difference. And we don't have any observed difference right now since we're just trying to know if there is a significant difference between them. No, if one is higher or one is lower, or they are just equal. So something like that. So meaning to say, what will be the value of this mu sub 1 and mu sub 2 will be 0 in our computation. Okay, I hope you get the idea on why we will going to use 0. So 0 here over the values of the s sub 1 squared and s sub 2 squared and the n1 and n2. So let's write here, s sub 1 is 47, or rather this is the n sub 1. The s sub 1 is this one, 226,000. And this is just a standard deviation. Okay? The formula is variance. So we need to have square here on the formula. So 226,000 square over the n sub 1, which is this one, 47. So let's have here 47 plus the s sub 2 square, the standard deviation of our second population, then we will going to square it, 243,000. So let's have here 243,000 over our second population sample size. So the sample size of Makati is 45. So let's write here 45. Upon computing this on calculator, I hope you already have your scientific calculator. You can get a value of 3.471 here. Now, let's have our decision rule. So, assuming, let's have there a normal distribution curve. Kunyari, pantay, lumihis pa. So, we have 0. And, ang atin is, since this is a one-tailed test, which is going to the right, so right-tailed test ito, our critical value is positive 1.645. So, let's assume this is positive 1.645, and this will be our rejection region. So, rejection region. Critical value. What is our computed? 3.471. And where is that 3.471? Assuming dito siya. No, 3.471. As you can see, our 3.471 is nasa loob siya ng rejection region. So, what our decision, no? Sa kapag ganyan ang ating setup, our decision now will be to reject. What should we reject? Of course, null hypothesis. Hindi natin i-reject yung claim ha, baka kasi doon kayo tumingin. Ang i-reject natin lagi, or yung fini-fail to reject natin lagi, is yung null hypothesis, not yung alternative. Null lagi. Kahit nasaan man sa kanila yung claim. No, na-specify ko ba yung claim? Ayun, na-specified naman. So, since we reject the null hypothesis, let's go back to our hypothesis. We reject this one. No, we reject this. So, rejected, meaning to say, we can support the claim. Now, the claim is correct. So, let's have now our conclusion. Since we reject the null hypothesis, we can conclude that there is enough evidence to support the claim that the means are not equal. There is a one population which is higher, no, higher mean. Hence, there is a significant difference in the prices of the average price of townhouse between Quezon City, which is in Quezon City, which is higher than Makati City, based on our alternative hypothesis. Okay? At alpha level, 0.05. I hope you get it. That's how we compare large independent samples using two population hypothesis testing. Okay, so if that's not enough for you, I have here my second example. So let's have our second example. Testing the difference between two means large independent sample. So almost same kanina. Here we have the operations manager ng sales company wants to see whether there is significant difference in the ages of male or female customers. So, gusto nila malaman, no, kung pinagkaiba ba. Ano ba yung female customers natin? Matanda or bata? Or baka mas matanda yung lalaki? Or baka mas bata yung lalaki? Something like that. No? Hindi nila kung may pinagkaiba yung edad ng mga customer nila, male and female customers. So, he selects, the operations manager selects a sample of 35 samples for each group. So, ano yung group na yon? Of course, male and female customers. The ages are shown here or on the next slide. At alpha level 0.05 on the table below pala. At alpha level 0.05, let's decide if there is enough evidence to reject the claim of no difference. Take note again sa term na ginamit, no difference. Meaning to say, the first group is just equals to the second group. No difference equal sila in the ages of the two groups. So, here's the table. We have here the mean of the male, which is 27.3, while the mean age of female is 28. Standard deviation of male is 2.4, while female is 3.1. Sample size is 35 and for the male, and of course for female, we have 35. So, since the claim is no difference, meaning to say, what will be our hypothesis. Our hypothesis now will be H sub O is mu sub 1, yung male, equals mu sub 2. No, lagyan natin ng label para alam niyo, mu sub 1 and mu sub 2. So, ayan. And this will be our claim. Diba? Sabi dun sa last part ng problem, ito yung magiging claim natin. So, H sub 1 natin, definitely, kapag naka-equals yan, yung isa will be not equal. Tatandaan yung nabanggit ko last time during the hypothesis testing introduction. So, mu sub 1 is not equals to mu sub 2. And this is not the claim anymore. Okay, so next, we have the level of significance based on our problem, given by the problem. Our level of significance is 0.05 here, 0.05. And the critical value, guys, I hope you have your table because I don't have the table in this PowerPoint presentation. The critical value upon checking the 0.05 level of significance, and this is a two-tailed test. Just look on the table for two-tailed test and 0.05 alpha level. So, upon checking, you can see there ang value niya, ng critical value, will be positive, negative 1.96. Okay? So, next step, almost the same kanina. So, gamitin natin yung formula na ginamit natin kanina, which is Z equals to X sub 1 bar minus X sub 2 bar. Minus mu sub 1 minus mu sub 2 all over the square root of S sub 1 squared over N sub 1 plus S sub 2 squared over N sub 2. So, let's substitute the values. We have X sub 1 squared. Ano yung X sub 1 squared natin? This will be the X bar. So, X sub 1 squared will be 27.3 minus 28, which is our X sub 2 bar. Square ako ng square. Bar yun. X sub 1 bar and X sub 2 bar. So, 27.3 minus 28. So, let's have here 27.3 minus 28. Now, same idea kanina. Mu sub 1 is, again, by the definition ng mga variables natin sa unang-una, binanggit ko, mu sub 1 and mu sub 2 are the expected difference. And we don't have expected difference right now dahil tinitignan pa lang natin. No? And as you can see on the given data, this mean is X bar, not mu. Again, mu is population mean. We just have here our sample mean. So, we don't have any value for the mu for both the male population and for the female population. Or rather, for the male dataset and the female dataset. So, I hope you already know what I mean. Meaning to say, we will be having a value of 0 here. Okay, malinaw po. So, next, let's have the fraction bar. So, over S sub 1. So, what will be the value of our S sub 1? We have here standard deviation 2.4. So, let's have here 2.4. And we have square on the formula. So, we need to square this over n sub 1 or our first data set. N. This is n. 35. Let's write here 35. Plus, we have the S sub 2, which is the female standard deviation, 3.1. And we need also to have a square on it over the sample size for female data set, which is 35. Okay, upon computing on calculator, just directly input this. It will give you an answer of negative 1.056. So, negative 1.056, let's try to have our decision rule and of course the graph here. So, just like before, ayan, medyo diretso na. So, 0. And the critical value, let's go back here. Our critical value is positive negative 1.96 because this is a two-tailed test. So, positive negative 1.96, let's assume this is the positive 1.96. Negative 1.96. Since this is a two-tailed test, we have the rejection region on both the tails of our distribution. So, this one is for the left part and this one for the right part. Okay, so for the right part, here's our rejection region. Okay, so we have already plotted the critical value. Let's try to have our computed value or the negative 1.056. So, negative 1.056. As you can see, negative 1.0 is something around here. Okay, so negative 1.056. And as you can see, negative 1.056 falls inside the non-rejection region. I hope you still remember that this region up to this point is a non-rejection region. So, non-rejection region. This is where the negative 1.056 lies. Meaning to say, since that is not included in the rejection region, we shouldn't reject the null hypothesis. We do not reject null hypothesis. Or, we are actually failing to reject. We fail to reject null hypothesis. Ayan. Hindi natin siya i-reject. Fail to reject null hypothesis. And that is at alpha level 0.05. And since we fail to reject the null hypothesis, our decision should be, we can conclude that there is no evidence of significant difference between the average ages of male and female customers. Again, let's go back to our hypothesis. Fail to reject null hypothesis. So, meaning to say, this is correct. No, we fail to reject this one and this is wrong. And the one that we fail to reject is actually the claim. Meaning to say, kung ano man yung kiniklaim nila dito sa problem, na wala silang pinagkaiba, yes, tama po sila. No, just like again on our conclusion, ulitin ko ulit, since we fail to reject the null hypothesis, we can conclude that there is no evidence of significant difference between the average ages of male and female customers at alpha level 0.05. Therefore, sa madaling salita, no, halos pareho lang po, walang pinagkaiba yung mga edad ng customers nila, lalaki man yan or mapababae man yan. At alpha level 0.05, we are always having this alpha level sa ating conclusion dahil may possibility na magbago po ito, no, yung ating magiging conclusion. Depende sa alpha na gamit natin. Okay? So, that ends up my presentation regarding the hypothesis testing two population and testing the difference between 2 means. Large independent samples. I hope this is clear with you, my dear students, and I'm looking forward for the mastery on the subject statistical analysis 2, and see you again on our next presentation. Thank you and keep safe always. Bye-bye.